Polio. That's. I love to spend some time on this infection because it shows it's such an exemplary success of the vaccination program. So poliovirus is the small enterovirus of the family Picornaviridae. It's a positive single-strand RNA virus without an envelope, and we don't know if there is any zoonosis for it, not that we know of. We don't know any animal that can be infected with the polio. It looks like we are the only reservoirs and we are the only hosts. Although we can consider the soil to be a non-living reservoir for the virus. Yes?
If a human has an infection and they transmit to, let's say, a dog or an animal, is that still considered a zoonosis transmission?
That's a great question. So if there is a transmission from human to an animal, it shouldn't be zoonosis, because when we say zoonosis, we specifically define it as animals to humans. Obviously, we were animals at a certain point. Okay. So the infections that can be transmitted from humans to animals, probably some influenza strains can be transmitted from humans to, say, pigs. I cannot think of anything else, actually. I don't think there are very many examples of it. But for this one, we definitely know that it goes from drinking water, for example, mostly drinking water, sometimes food, and it infects humans. And then we shed it in feces. And we know polio as causing meningitis and paralytic illness, right? However, the primary infection is of the epithelial cells in the intestine. So it's mostly intestinal infection that goes mostly asymptomatic. 1 out of 100 to 200 cases actually develops neurological consequences. So if you see somewhere that there's an outbreak of polio and say 200 people developed paralysis, it means that 20 to 40,000 people were actually infected. They just never had any symptoms or had like fever. And if you think about the transmission route, virus that enters central nervous system ends up in the trap. There's no transmission from CNS. Does that make sense? There's no CNS infection doesn't lead to the virus transmission per se. So frequently it is referred to as a spillover event. The infection in intestines is so massive that virus just happens to go into the neurons. Does that make sense? Okay, good. So this infection caused around 50,000 cases of polio every year in the US, which is a lot. If you think about it, it's really a lot. So vaccination program became really, really important at a certain point, and two people, Jonas Salk and Albert Sabin, started to work on the vaccine. And you probably saw did you ever see people who suffered from polio? Franklin Delano Roosevelt was one of them. I actually saw when I was growing up, I saw older kids who contracted polio earlier. And it's a crippling disease. It can be partial paralysis of the lower limbs, for example, so people have to constantly use crutches. So it's not so much deadly disease, but it's crippling disease. It's a debilitating disease. Now, Jonas Salk was the first to develop the vaccine, and the vaccine was inactivated. Okay, So pretty much the wild type poliovirus, and there are three types of polioviruses, three subtypes, 1, 2, and 3. They were inactivated using formaldehyde and then injected. And guess who was injected first with that vaccine? His kid. Well, himself, his wife, and his children were the first people who received the vaccine, and it was absolutely safe. Unfortunately, there was an accident, and I don't remember the name of the company. It was a company based in California. They were making IPV vaccine, and they didn't follow the inactivation protocol thoroughly. And unfortunately, Salk, who was invited to the company to check the inactivation protocol, was pushing the release of the vaccine. And incompletely inactivated vaccine samples caused a massive, thousands of people were infected as a result of that vaccination campaign. So it was a big gap, and it sometimes anti-vaxxers use this argument against safety of the vaccines, but it was just a shining breach in the proper technique of vaccine production. Does that make sense? So it wasn't related to the vaccine per se. It was just neglect of people who were making it, and to some extent neglect of Jonas Salk himself. After that, it was investigated, compensations were paid. I don't know if people actually got imprisoned for it, but since then there were no accidents like that. And this program was very successful. Few years later, after the vaccination campaign started in the US, Albert Sabin came out with the live attenuated vaccine. The advantage of that vaccine was that, so let's recall what's inactivated is. It's dead, right? Well, quote unquote dead. Attenuated replicating virus. But it's weak virus, right? Which one do you think will give you better immunity? Live, right. Turns out there's so-called intestinal immunity. When you are vaccinated with inactivated vaccine and then somehow get the virus still replicates in your intestines. It just doesn't cause the disease in you. When you are vaccinated by the attenuated vaccine, it provides the intestinal immunity. So the virus actually doesn't replicate in your intestines. You see the difference? Pretty much virus is completely shut down in your organism. Here's the problem. Dr. Sabin with his vaccine, which has another big advantage, it's oral. It was actually applied as a little drop of vaccine on the piece of sugar. Okay? So it was really easy to administer, much better than the shot, right? But you have a government-sponsored campaign that is using IPV. And Sabin is pushing OPV through. Obviously, US government declined the request for the clinical studies. Doesn't make sense. But Sabin was a good friend of one of the Russian pioneers in virology, Professor Chumakov. And Chumakov actually told him, dude, let's roll it out in Russia. And the regulatory mechanisms there were quite different from US. So pretty much there was no small clinical trial. They just started to use it. It was probably the largest clinical trial ever in the history of humanity. Millions of people got vaccinated. Tens of millions. The whole population got vaccinated. And it turned out the vaccine worked very good. What would happen if it wouldn't? They would probably, well, nothing to Sabin, but the Russian guy would probably get imprisoned. Okay, so it was a wild bet. but it paid off. The downside of the oral vaccine is that first, it causes so-called vaccine-associated poliomyelitis. Vaccine-associated polio. Second, turns out that type 3 virus, when replicates in the human intestines, reverts from the weak one to the wild one. So people who receive attenuated this oral vaccine start to shed pathogenic virus in the environment. So it becomes a self-perpetuating cycle. You have to vaccinate people against the virus that they will shed in the environment because the weak one becomes the full strand. That make sense? The only way out of this, so this is what I was referring to. Only way out of this. Any ideas? Hint, polio can survive outside for about a year. Huh? Burning feces sounds not really great. You start with IPV, you start with an activated vaccine, which gives person a protection against polio. Then give oral, then continue to give inactivated again. Or you just completely switch to inactivated virus, because eventually when the whole population becomes immune to the virus, when you have 100% coverage, the virus has no reservoir and no host and just dies out. Does that make sense? That's what happened in the United States, actually. That's what happened. Question?
I was just asking, this says dead next to it?
Yeah.
Okay.
So it's pretty much virus is killed. So in the United States, we use only inactivated vaccine. But the problem with it is that you have to deliver 3 shots. They have to be timely. So it's a logistical problem, and it's also more expensive. Oral vaccine is cheaper, and there are less consequences if you forget to administer it in a certain time. So it's often a choice of the developing countries. Both vaccines can achieve the goal of eradicating polio. Currently, there are 3 countries in the world, okay, 4, that still report polio. Any guesses? That's offensive. No. No. Yes. No. Good guess, but no. Come on, it's a communist country. If you're not getting vaccinated, you're going to be imprisoned or killed. Well, I'm kidding, but everybody gets vaccinated. Who said India? Good, India, number 1. Because of the huge population, they can't reach everybody, probably some religious issues and so on. So India, number 1, they're getting better. Nigeria used to be. So in order to be considered free of poliomyelitis, there have to be no cases in 5 years. So I think they on the 3-year streak. The reason was at a certain point government got completely insane and decided that all the WHO programs to vaccinate people were to establish the mythical quote-unquote control by the Western countries. Although it was entirely sponsored by WHO, kind of, you're not even paying for the vaccine, we're paying for the vaccine. So Nigerian government shut down the vaccination program. They had a spike in polio infections immediately. Then they realized what they did, and they allowed the medical missionaries, let's call them this way, to get back to vaccination. Something else. Country that is not a state. No. No, I mean, like, officially it's a state, but technically it's not really. Oh, no, it's a state. Come on. Castro's dead, but it's still state. No, it's a state. Afghanistan. There's no state there, right? It's like there is a central government that doesn't govern anything, technically speaking. So Afghanistan is rampant, and so do several regions of Pakistan that at the border that are technically not controlled by Pakistani government. So wherever you don't have a centrally implemented vaccination program, polio raises its head. Now it's Ukraine, actually. In Ukraine, there are autochthonous polio transmission cases now because of the political and economical turmoil. Okay?
The live flu vaccine, like, didn't they have that on the market for a while through the nose?
Yeah, well, let me finish the whole shtick, and I will answer this question. The live flu vaccine, let's remember that. So pretty much the idea now that Bill Gates, by the way, is pushing it through, is to eradicate polio in the world. Huh? It's been closed for like 15 years. Initially, WHO promised to eradicate polio by 2000. Then it was like 2010, now it's 2020. The main point is, should we spend the absolutely abhorrent amount of money, actually billions of dollars, to eradicate last 200-300 cases of polio? I think we can find better solution to it. I'm not saying we should stop, no, but just let it just go the natural way. That's life, you know. We have to continue vaccinating, and let's do it, but let's not set the goals. I think, you know, maybe spending money on measles, okay. With measles, you really have to change people. Don't think we have that much money in the world to really change people, unless you're willing to pay them for vaccination. Another infection that causes paralysis, it's paralytic infection, tetanus, that is called by gram-positive spore-forming Clostridium tetani. By the way, the best argument when you debate anti-vaxxers. When they say no vaccine, tell them, okay, get rid of tetanus shot. Next time they step on the rusty nail, let them play Russian roulette. Okay? Because what happens, this microbe produces the toxin. You can see a picture right here. That's how it looks under the microscope, and you can see the spores forming in the cells. So it produces the toxin, okay? And this toxin, interesting, it blocks the inhibitors of muscle contraction. So it acts on the spinal cord. And it leads to spastic paralysis opposed to flaccid. So flaccid is when you cannot contract the muscle. Spastic is when you cannot relax the muscle. So example of tetanus can be seen here. It's usually the patient is bent backwards, jaws are locked, so patient cannot open the mouth, and hands going up like this. Okay? There is a vaccine, which is essentially a toxoid that produces antibodies as a component of DTaP. Does that make sense? It's very effective. But every time, you know, you get, like, I don't know, really bad wound, you should get tetanus shot as well, just to be safe. Because, as any vaccine, is not 100% effective. Okay? Now, what you have to understand is that the microbe does not have to replicate. If it dies, I mean, if it releases toxin, microbe may be gone, but if toxin is in the circulation, you're going to have that problem. Does that make sense? So antibiotics don't really help. It's antitoxin that would help. Botulism is a flaccid paralysis. So again, it's another Clostridium. Now it's called botulinum. So neurotoxin blocks the ACH release. Okay, so you see, doesn't. So that's the no ACH release. When you have no acetylcholine released into the synaptic cleft, neuromuscular junction, you have no signaling, right? No signaling on the muscle, no muscle contraction, no control of the muscle. Here's the picture of Clostridium botulinum here. And, you can see those little rods with the spores inside them. The botulism, the most common, is the foodborne one. Clostridium loves to get into the preserves, improperly prepared, okay? And when people eat them, acquire foodborne botulism. Question?
Is that why I should ask? Can't you leave food in a can, like an aluminum can?
Oh, it's
My mom would always tell me, "Oh, you get botulism," but that doesn't make any sense.
no. When you talk about the like the metal can,
Yeah, like when it's like canned goods and you can't.
as far as I remember, one of the components, whatever covers the can from the inside, when you leave it open, it starts to get oxidized and it enters the food and it's toxic. So it's entirely chemical. But botulism, if you do especially like homemade stuff, homemade preserves, if you didn't sterilize it very well, then it can pose a problem. Often you can kind of detect it if the lid starts to pop out on the homemade stuff. So gas accumulates because it's anaerobic, and it produces, I think it's hydrogen mostly. So it kind of pops out because of that accumulating hydrogen. You should not really eat it. Okay. So botulism, most common is foodborne. Infant and wound botulism usually goes into the bloodstream. In all cases, it causes the flaccid paralysis, and effects of Botox are essentially mediated by the botulism toxin. When it's injected in a certain area, okay, it blocks the acetylcholine release and relaxes muscles in that area. That's why, by the way, if you would look at the people who abuse Botox, their face looks like a mask because they can't move their facial. They have no facial expressions because they can't really control the muscles. Does that make sense? Trypanosomiasis is another fantastic disease. It's a protozoan. You can see Trypanosoma cruzi swimming among the red blood cells in a blood sample. That's, by the way, one of the common methods for to diagnose that disease. So this is transmitted by tsetse fly. It's a zoonotic disease that resides usually in like cattle, okay, buffaloes, domestic cattle, and so on. And biological vector, the tsetse fly, when it bites humans, it transmits the disease, it enters the bloodstream, eventually spreads systemically into different organs, eventually reaches the brain, and the damage, the CNS damage, lassitude, and sleep disturbances. In this case, sleep disturbances mean that person becomes sleepy. So, not active, sort of in a state of almost stupor, okay, and sleepy. So it's kind of illustrated here in that picture. She kind of looks a little sleepy. But it also is accompanied by various systemic changes. The lymph node enlargement, the splenomegaly, it invades joints, it can enter the heart, causing myocarditis, so there can be all kinds of consequences. The disease develops, it may develop for months, it may develop for years. There is no vaccine against Trypanosoma brucei. The only way is to control the vector. One very interesting thing is, it's a zoonotic disease. So the microorganism can be found in the ruminants. There were experiments in Africa when settlers brought animals from their home countries, like I don't know, longhorns. I don't know if they brought longhorns or not, but like European cows, you know, they were brought to Africa. They didn't survive there. They died of trypanosomiasis. Turns out the local breeds, through long coevolution, adapted to trypanosoma and don't get sick actually. That's pretty interesting. Buffaloes don't seem to get sick and to die from trypanosomiasis. Yes.
So for certain zoonotic diseases that reside in cattle, per se, what if you were to like vaccinate the cattle?
It's a great question. Yeah, for zoonosis, can you vaccinate? By the way, that's one. So yes, you can vaccinate animals for Brucella abortus, which is the causative agent of brucellosis. You can vaccinate cattle. Another interesting thing is rabies prevention. There is a country in Europe, which I think they declined to be counted as a part of Europe. Any idea what the country is that? The country in Europe that don't really like Europe. Britain, okay? They're technically Europe, but they always set them apart. It's a rabies-free country. One of the major reasons for it, it's an island. So they vaccinated all the animals. Any ideas how can you vaccinate the animals? Except for chasing the foxes with a syringe in your hand. Like spraying?
Yeah.
I think it's easier just to use napalm and just burn everything to the ground. No. Yeah, that's kind of problem. How do you know? Well, okay, you don't really have to know, but no. Well, food. So what they've done, and it's really interesting, the program. They took a pox virus similar to, like, from the same family as smallpox, and incorporated rabies antigens into the pox virus. Then they use this pox virus, they infuse the baits, like pretty much pieces of meat, with that pox virus vector, and they distribute it in the forests using helicopters. So they just drop it down, and then animals eat it, get vaccinated, and they stop the zoonotic transmission of rabies, which I think is pretty awesome. The only thing, the downside was, they use it in France now, they use it in Switzerland. The downside was, I think it was in France, a dog picked up the bait, brought it to the owner. An owner was an older woman who was on immunosuppressants, the transplant, and she grabbed the bait, and pox virus, that is a vaccine, actually penetrated through the wound. She was gardening at the time, so she had multiple scrapes, penetrated through the wounds. She developed a mild infection. But think about the coincidence, like how many things should have fell in the same, like the same bag too, for everything to happen. It was actually a clinical case described, but actually it's a pretty successful program. I don't know why they don't do it here.
So that would mean that we can eventually eradicate rabies.
We can, yes. We can, unless there is another reservoir, for example, that would not touch the bait. Okay? That can be a problem. Going back to your question, the live flu vaccine. Who got vaccinated against flu this year? 4, 5 in the microbiology class of, okay, discounting me, okay, 4, 3, 5, 8, 6, 14. I don't know if Edward and Crystal were vaccinated, but 25% in the microbiology class, that's the poor coverage, trust me. So live vaccine. So what's about it?
Like, why did they get rid of it?
Okay. That's the answer.